Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our quick knowledge series. And today's topic is about permeability change due to water flood. So if you're currently working on reservoir simulation and you are focusing on the permeability and the simulation handles water flood case, basically if you're a reservoir engineer, reservoir simulator and you are evaluating a reservoir with water flood, you are focusing on the permeability, maybe this video will be useful for you. All right, so let's talk about this. Permeability change due to water flood. Right, so first you can read it with me. During water flood, pore throat structure of the porous media in the reservoir changes continuously. So let me change my pen first. All right, so changes continuously. This is very important, which causes the great challenge in reservoir modeling and simulation. The results show that the pore throat structure of porous media becomes more complex and more heterogeneous after water flooding. Okay, and the pore throat parameters, for example, porosity, permeability, the maximum pore throat radius, average pore throat radius, and the sorting coefficient will change during water flood. All right, the fourth bullet. It is reported that due to the long-term fluid-solid interaction, all right, so we have fluid and solid interaction here, the rock and the injection fluid. The pore throat structure of the porous media in the reservoir will change continuously or will change continually during water flood, causing the great challenge in reservoir modeling and simulation. And lastly, the parametric study suggests that the pore throat structure of porous media become more complex and more heterogeneous with increasing pressure gradient or increasing injected pore volume, right? So if you want to read about this, you can go to this paper. Okay, you can get this paper on One Petro. And the next one is this table. This is very important. So we have several papers commenting on the permeability change due to water flood. Okay, of course, I will not talk about all of this paper, but I will just go through this table. And if you're interested, you can go to this paper and you can also go to each of these papers. Okay, so the first paper says that porous media permeability will decrease. All right, so permeability decrease during water flood. And they suggest that due to or using theoretical model. And the next one, Lin et al. From 2001, they used experimental tests and they say that porous media will decrease due to water flood process. And then Li et al. In the next year, 2002, they conduct experimental tests and core well data analysis. And they said that variation of pore structure after water flood will be affected by rock lithology, rock permeability, and minerals. Okay, basically, they agree that permeability will not be constant throughout the water flood, but there you can expect there will be permeability change. Okay, so that's the third one. All right, we can say permeability is a function of time or time due to time during water flood and pore volume injected during water flood and so on and so forth. Okay, and Zhu et al. 2004, based on core well data, logging analysis, laboratory core data analysis, they say that after water flooding, the variation of porosity is not obvious. However, permeability changes apparently. Okay, so permeability will change. Okay, permeability will change. And Kai et al. 2004, core well data. All right, and then the whole microstructure will be improved after water flood. However, the variation of the microgeological features are affected by the lithology, original reservoir storage capability, and the kind of the wells. All right, so again, permeability will change. Permeability will change. Permeability is not constant during water flood. Guo et al. 2012 experimental test. Porous media permeability decreases during the water flood. All right. Liu et al. 2012 theoretical model using fluid-solid coupling model. Porous media permeability increases during water flood. So they said that permeability will increase. Wang et al. Porous media permeability increases during water flood. They use pore network model, right? And Zhang et al. Experimental test using marine sandstone. They said that permeability increases during water flood. So we have some papers say that permeability will decrease. Some papers said that permeability will increase. Some other papers said that permeability will change throughout the water flood. So my point is, if you are currently evaluating on simulation and basically you said that permeability must be equal with, or permeability with must be equal to the permeability based on log or based on core. I think using this information here, we can say that don't be too rigid on permeability. Don't expect that permeability will be constant. And of course, don't expect that the permeability, the average permeability, and the effective permeability in the drainage area will be exactly the same with permeability measured using log or core. All right, because the depth of investigation, they're they're different significantly. Using core or using log, the investigated radius is maybe several inches. But if you're evaluating on pressure transient analysis, production analysis, or a reservoir simulation, you are talking about hundreds of feet, hundreds of meters, even kilometers. All right, that's the first thing. And the second one is that if you have water flood, don't expect that permeability will be constant throughout the life of the operation. No, permeability will change, okay, due to fluid and solid interaction, okay, due to maybe geochemical reaction, okay, maybe dissolution, precipitation, all right, and maybe erosion due to production, erosion due to water flood, all right. So permeability will change continuously during the water flood, and it's logical, okay. So again, if you are currently focusing on simulation, focusing on water flood, focusing on the permeability, I hope that after reading this paper or watching this video, we have an open mindset that yes, permeability, maybe it's not constant, and maybe I have to open room for the possibility that the permeability will change, especially in the case of water flood, right? So that's for our quick knowledge video for this episode. Thank you so much for watching. I hope this episode is useful for all of us. Thank you so much and see you again on the next quick knowledge video in this channel. Thank you.